This is the part where we have virtual beers, right?
I have virtual tea and virtual water. I'm setting up the stream on YouTube as well. So it's the first time I'm doing this kind of meetups via Zoom. So yeah. I hope we go ahead. So we are live as well on YouTube. I would say that I will resume recording, and we are off. So we have almost 40 people in. So it's pretty cool. So welcome to the very first virtual edition of our meetup. We've been through some hard times, everybody. So that's how it works. We better get used to it. At the beginning, I thought, oh, we're not gonna do just another virtual meetup, because this is gonna be for some time our new normal. So we'll just go with the flow and start a regular series. We're already planning for the next one, probably in about a month. So stay tuned for more. Let me share just a little introduction that I have. This one should do. Just some. I think you can see my presentation full screen.
Yes.
Yeah. So this is our 45th meetup and the very first virtual edition of the Dutch Kubernetes meetup. So we are part of the official network of Cloud Native Computing Foundation meetups. And today we're welcoming 2 new partners, sponsors, collaborators with Palo Alto Networks and Go to Amsterdam. So we don't have an announcement yet for Go to Amsterdam, but Natalie is on the call, and we've been working together to organize this, and she may send you an email or keep you updated on the status of Go to Amsterdam for in the future. And Anna is one of the renowned speakers at Go to Amsterdam, and Ramon is from Palo Alto and will show us some magic about Kubernetes security. Because you are here, yes, this is virtual and there is a chat, so please also be careful what you write in the chat. So because this being part of the official network of the Cloud Native Foundation, we also have to adhere to the code of conduct of Cloud Native Foundation. So when in doubt, ask, or you can report violation to me. One small announcement. We were very looking forward to the Kubernetes Community Days in Amsterdam in 2020 in September, but we've been, of course, looking at what's going on in the Dutch society, announcement from the Dutch government. So we decided to postpone it to 2021. So even though you technically can do an event in September, maybe, we didn't want to rush it. We didn't want to risk it. Our health and the health of the attendees is first. So we just decided to postpone it to March 2021, and we will also announce it very soon. There is a poll. I think you can see the poll. So tell us what you want to see here, right? So this is also a new experience for us, for everybody. It's a virtual meetup. So, but we want to keep the interactivity that is fundamental to the meetup experience, also through your own screen and webcam. So that's not exactly easy, but with your help, with your suggestions, we can make it happen. So we are on the Kubernetes Slack. We have a channel called NL Users for Dutch users. So please join there and let us know, let me know, and the other organizers as well, what you think, and use the poll here. So after the short introduction, Anna, you should be able to share the screen.
Sure. I was supposed to start at 2:50 your time, but I can share my screen.
Oh, yeah.
That's in the meeting. I'm just according to the schedule. Like, I don't know if more people are going to join. Just saying.
Sorry for that, but let me see. No, you're right. But we have already 50 people. So
I can tell you that from my own experience with virtual meetups via Zoom, people are joining even 15 minutes later, and you know, it happens. So in Romania we have the software craftsmanship community that where we speak in Romanian, and at the meetups, that at least the ones that I hold online after this coronavirus situation happened, at all the meetups, people join like, okay, maybe 2 minutes earlier, and even 15 minutes after it started. So usually I wait like.
No, I had 22 people in the waiting room before starting, and we are now at, I mean, we're going steadily. People are trickling in. I'm also manually admitting people, so maybe that's not exactly the best way to do it. So
the thing is that because of Zoom's latest developments,
maybe it's better this way. maybe it's better this way. So we're also live on YouTube. I can pass the link. I think. Yeah. So just because then we don't need to. I mean, I'm also recording this, so but probably YouTube will also offer the recording right after this. It's on the Cloud Native Amsterdam YouTube channel, so we have to see. I think we are good. So we are at 7 minutes in. If you are ready to go, probably could be the right time.
Okay, I'm just gonna wait 1 more minute, sure, if you allow me.
Oh, of course.
Just want to check some things. Not sure if I'm sharing already.
We see the
first slide.
First slide of the presentation, yes.
Okay, cool. I was just gonna check the YouTube to see if it's saying okay. Come on.
There's always a delay, of course. This is
oh yeah, I forgot about that one.
This is known and it's okay. It's I didn't advertise the YouTube link, but I just keep it as a backup. And I know that I've been into other virtual events, and the thing is, you have to manage 2 chats, YouTube and Zoom. But I think for now we have everybody in Zoom. So if there's a question, please raise it in the chat. We don't have a QA section. Maybe I didn't enable it. I'm not sure. But there's a chat, and if somebody has a question, of course, let's not interrupt the flow of the presentation. But we'll collect the question. And we can answer them at the end if you prefer like this, I guess.
Okay. I prefer like this. Well, anyway, my 30 minutes talk is more than 30 minutes, so it's fine for me if we can already start. At least I'm not going to have the pressure of 30 minutes.
No pressure.
And would love to also get some questions, because the talk of today is a little bit more theoretical, and it's on the theoretical side, and there are many ways of tackling the subjects that I'm going to talk about. So I'm welcoming more and more questions on the topic. So, okay, let's get it started. Hopefully my slides are moving. Just let me know if something bad is happening.
Yeah.
Okay, perfect. So first of all, let me introduce myself. I'm Anna. I'm happy to be here with you. Honored to be part of this meetup. What do I do? Well, I am a custom application development enthusiast. I work most of the time with applications that are Java-based, but given the Kubernetes situation is not Java anymore, so there are many more types of frameworks involved. I'm also specialized a bit in the IBM cloud, and since last year certified in OpenShift. I'm a Kubernetes fan and continuous learner in this subject. So I'm still learning. There's always something that I'm discovering as a wow. that could have been done. And together with my colleague, Victor Renta, who's also a very renowned speaker, speaking on various subjects about Java, performance, and architecture, we have co-founded the Bucharest Software Craftsmanship community, which is a community where we mostly speak in Romanian at our meetup. So because people say that it's okay to listen English at the events, but they prefer to their native language just to feel more comfortable. We have a series of online meetups, and we talk about what we did, what we could do better. And of course, we're welcoming new speakers also from Romania's side to share their experiences and what they do at work, because a lot of people do awesome stuff at work. They don't get the chance to go to conferences, but they can always share it with the community. And in the talk today, I want to talk to you about anti-patterns. And I think that my manager asked me, why are you doing this talk about anti-patterns and why not talk about patterns? And I said, well, patterns, I think there are books about patterns. Patterns are everywhere. And why not talk about what can go wrong and what can go wrong from good patterns, maybe. And by the way, all the opinion in the talk today here are mine, and please feel free to contradict me and to tell that, no, you're not right, Anna, I believe differently. I'm welcoming that. And of course, this is how I also improve. So basically, what are anti-patterns? This is the definition of Wikipedia. But an anti-pattern is typically a pattern that is commonly used, but is ineffective and counterproductive in practice. Anti-patterns actually sometimes are ignited by good patterns that were misunderstood. And it ended up in being a bad experience. And in the talk today, we're going to talk about the bad experiences too. So what's about system stability? The system stability, well, there's no such thing as a, let's say, official definition about system stability, but a robust system keeps processing transactions even when disruptions occur. I mean, even when transient impulses or persistent stresses or component failures disrupt its normal processing. This is what we typically call stability. Or in, let's say, more colloquial language, users can continue to work with your system even though those disruptions occurred over there. So you can still do some work when some things are not working as great as you anticipated. So those being said, let's go into the first anti-pattern that I would like to discuss with you. It's about integration, communication, and composition. So these can have a lot of flavors. And I just kept a few of them based on what I got into experience. So first of all, when you design a new shiny distributed system, it can happen that you're integrating with some other parties that are not necessarily part of your system. Because there's always some very good system that is still legacy that won't be moved too soon to your new designed distributed system, or maybe it doesn't make sense to be in your new system, the one that is Kubernetes based. So it resides somewhere outside of your own reach, or even better, you cannot do anything to change its behavior or interact with the team that manages that system. So in the case that you are having integrations with systems that are based on synchronous call and response or queue-based publish subscribe messaging systems, and I'm talking here about things that are outside, not necessarily about Kafka and all these things that can be managed maybe inside Kubernetes, or you're having system-to-system messaging via SMTP or SMS, you're actually having the first urge to do an integration via synchronous communication with the software that is actually forcing you as a calling system to wait or stop from what you're doing. So I've seen this many times, like, okay, so we're integrating with this third party. The first go-to of a developer and is to just go directly and just consume that service without even thinking that it might not be all the time up and running and 24/7, and you're just propagating some bottlenecks that used to be there also into your system later on. Another flavor for these kind of integrations are, of course, containerizing this kind of middleware as is. So people have this urge and this desire to put everything at Kubernetes level. because, well, it's easier to manage from a network perspective. It's everything there, so you don't have to preoccupy yourself with something that's outside. So if it's inside, it's better. You don't have to think of what's going to happen in the outside. And of course, these are troubling because you're just, pushing something that maybe it's supposed to run separately on a VM or wherever else and into your Kubernetes-based system, and you're not doing anything good. You're just, again, putting a big bowl of mud or something that was big and heavy before to be installed into Kubernetes, and no performance improvement at all. And of course, this is sometimes, this kind of event pattern is mainly, from my point of view, caused by a distorted usage of declarative deployment pattern. So everyone is thinking like, yeah, I have things to do with Kubernetes, even though I have to integrate with another system. What I'm going to do, I'm going to write a deployment, I'm going to write a service, and boom, everything is working perfect. And I'm going to do many of these. And this is my very shiny distributed system that it should work 24/7. But it doesn't, because it's integrating, unfortunately, with a system that's not 24/7 available. So this is the first kind of case with some examples and symptoms, but the problem can go even further. So it can be even worse, because when you are integrating with legacy, sometimes you get to the situation where your requests may be sent but not receive a reply. So many times you're integrating, you're sending some data, or you want to get some data and you get nothing back. That's awesome. The best, there's another case. It doesn't happen this often, but if you don't have control of the other party of the system, you can get to the situation when you get a different response format, which is also great because you're expecting something and you're getting something else at your application level. Thirdly, because you're using synchronous calls, you're actually amplifying or facilitating blockages and cascading failures. Let's just say that, well, in case of microservices, cascading failures are less often if you're going with a shared nothing architecture, and let's say you're very good at isolating things and you're not cascading anything in such a vertical architecture. But you can easily facilitate blockages. So for example, if you are, say, using this third party that would give you prices for your products, and this third party is not available, you don't get the actual prices of the product in time, and it can get you to blockages if you are consuming that synchronously, of course. And it's not very fun for the users. And of course, you just managed to move the idea of tightly coupled middleware that used to exist before Kubernetes to Kubernetes level with this kind of approach. And you're also amplifying the shocks to your system. So your new shiny new distributed system is not necessarily doing the job as expected. So what solutions are there to address this? There's some application level solutions. There's the old circuit breaker pattern. I think everyone is aware of this pattern. Is available even before Kubernetes, but people have rediscovered it with microservices hype in the last years. Also, they rediscovered it again with Kubernetes. It's very popular. There are a lot of examples over the internet, and this is why people are in real life applications, their first implementations, well, it doesn't break. Well, it breaks something, but not necessarily in the good way. So the idea is that why to send subsequent requests to a service that is unavailable when you know that that service is down, then don't send any requests, just send the response to the user, and that's it. So no necessarily to go to the roundabout to the service and just reply to the user. That's fine. But also there is something that needs to be considered when applying the circuit breaker pattern, to consider the delayed retries. And a lot of people are not thinking necessarily to retrying, when they're applying this, because they see, at least at the application level, they see a lot of examples when, okay, it's not working, then I go to the fallback method and that's it. And they think only to the fallback and that's it when it comes to configuring at application level. And there's another and very important thing, and this is typically very important for Kubernetes, is to report, record, and correlate the state changes. So a very good monitoring can save the day anytime. So always record what's going on with your system. It used to be this feeling like, oh, it happened only once. Maybe it's not gonna happen again. Oh, it happened only twice. I don't see any pattern in this bad behavior happening. Maybe it won't happen again. But just living your professional life like this is not going to bring you anything good, because one day probably it will break and it will not be at the level of, let's say, of testing or staging or another intermediary environment, but it's going to be directly in the production level. So there's some solutions at the application level. And this is just a sample, a very, very small sample of configuration example of Spring Boot with Resilience4j. Now, this is just a snippet because the real deal is long and scrollable and wouldn't have fit in this. And it's not the point of this talk necessarily. But what I want to draw the attention to is that when you're thinking that the application level of configuring the circuit breaker, you have to have a sliding window, meaning you have to have like a count-based window to store and aggregate results in order to check if the failure rate is above or below the threshold that you set. You need to have like a wait duration, like the time in seconds to wait in the open state of the circuit breaker before making any requests to the dependent service. And during this period, by the way, you assume that the service is down. And of course, you need to have the allowed number of calls in the half open state if you are working with a half open state too, but most of the people also configure the half open state and look at it. And of course, the failure rate threshold. So all these four aspects are very important in configuration. So you start with this, and of course, you are configuring on top of this down the way. Resilience4j in particular, because it's Java related, has even the retry part ready for configuration. And you can go and tweak it and make it very customizable and improve it at a very, very fine-grained level. So I really like the library if you're working with Spring Boot. For other frameworks, there are some other options as well, and we can discuss those, by the way. So is this enough? Well, yes. If your end user is happy that real data is not in the response. So if you have somehow identified a way to send to your user that information that is not necessarily disturbing him or making him upset that he's not getting the real deal, and he's patient enough to get the real deal when you're going to have it, then it's fine. So you found a way to compensate for the user's anxiety to get something real. It's not going to be bad math. But it's also good if your fallback method retrieves a unified satisfying response. So that thing, please try again later, or any kind of response, generic response for that is going to be good. But also speaking from my own experience, let's say the prices part, okay, you don't get the real prices. You get like, we're sorry, we cannot show you right now how much it will cost you to shop online with us. Please try again later. For me as a user, that was not very satisfying because I won't be able to continue my purchase. And I'm just gonna say, yeah, I'm gonna drop. So that's lost business. Not necessarily satisfying. Nothing is going further from the user's point of view. So he cannot finalize what he wanted or she wanted because they cannot see the real deal. So whenever you need the real data, that's when only this solution is not applicable. And unfortunately, the examples that are over the internet, which are starters, are encouraging developers to put this generic information in the response. But when the real situation kicks in, that's when the terrifying part comes for developers. So, but there are some transition solutions, of course. So there's caching. And I'm going to talk only about caching in this case for the transition. So cache solutions work really well to cover the part where you need the real data. And there are two ways of going for the cache solution. You can determine the outage pattern of the party that you're integrating with. And some of you are going to think, how can you determine the outage pattern of something that you don't manage? This can be done even if you don't manage that application, but you get environments to test that application. You can stress test and load test against that application, against that type of resource that you're integrating with. And then you determine an outage pattern. Based on your outage pattern, you can design a cache solution. Or based on the maintenance window. So this is one of my cases. We used to have an integration with a legacy third party managed by another team. And every Friday, 3 p.m. Romania time, they used to send me an email like saying, "Dear Anna, between 3 p.m. and 6 p.m. your time, the following application is not going to be running. We're doing maintenance. So please be aware of that." So if you're in a lucky situation, you have this maintenance window announcement, you know how that in that time, you need to have the data available until that thing is getting updated. Of course, there are some downsides to this approach also, and probably we're going to discuss this after the talk, because I already envisioned some also in my solutions. But the idea is to start somewhere in addressing the situation and not just let the generic answer to the user. And of course, the cache solution can be really easily tested. You can just rapidly, just to prove your point that it's going to work, you can just rapidly spin a Redis instance. I'm just putting here the command for Helm, because whenever I need to test something that it works from connection point of view, I'm trying to use the Helm charts because they're the most easier for me. I'm just configuring the values.yaml with my necessary data and just throw it in my local, and I have something up and running to test my assumptions. But besides introducing the Redis, you need some logic to process the information, right? So you should keep the circuit breaker pattern. And you should also add a 2-layer cache solution. So this is my approach. I would add a 2-layer cache solution. The reason for that is because a 2-layer cache solution would have a cache which has enough time to live, but starts already to refresh its entries before they expire. So in case of a downtime, the entries will still be there. Now that's the case when the downtime is not exceeding the time to leave, or we have a cache miss. But let's just say that these things can be corrected in time in the solution. And the reason why I'm mentioning this is because I also hit this kind of issues in implementation. But this kind of transition solution works really well, and it can save or it can improve what you already have done at the application level. So the transition solution would say that we'll try to find if the data, the price that you're needing is in the cache. So you have a cache hit or a cache miss. These are the 2 options. So in case you have a cache hit for that price that you're searching, you check if the time to leave of the first layer cache expired, because you want to see, okay, it's a cache hit, but I want to see if the data is good there stored or not. So in case that the time to leave did not expire, you return the response from Redis. If it expired, then you go to the second layer cache and find the entry. So what you do at the second layer, you want to make sure that, well, it's fresh also, right? So you try to call the real method. On success, you are storing the new result and you put the proper time to lead, so it's fresh. It's fresh in the second layer, so now it's good data, it's fresh. If it's not, you extend the existing time to leave of what you were having there, because remember, you're going to the second layer cache and you're finding the entry. So you're extending the time to leave of what you had at the second level, and you're retrieving what you already had there. This is an idea of processing the failure and to retrieve something palpable to the user so that you don't lose the user interest in that piece of data. Now, if you have a cache miss, of course, you need to call the real method. In our success, you store the result. This is the happy path. On the not so successful part, well, you return a result covering the miss and record the failure. So by result recovering the miss, I'm talking about, well, there was no entry in the cache. So there is no way for you to give real data to the user, but you should tell him, I'm sorry, dear user, for this information, for this request of yours of price, I don't have data or something beautiful, that generic answer. But the idea is that to narrow the generic answer that you used to send in the fallback before only at the application level, and to like eliminate some cases where you can actually send some real data to the user and make him happy. Those being said about the interaction outside of Kube. But what is the piece of data that is not behaving as expected in an integration is at our level. So it's at our level in Kubernetes, and it's not residing outside. And probably you're familiar with these guys here from a really good cartoon that I personally like. So what solutions are there? Something tried. Of course, traffic. Because when you're thinking like, okay, if I'm thinking of elevating circuit breaker and integrations, I'm working with, of course, with routing and how I'm going to route things. So I'm thinking of ingress. And the traffic Kubernetes ingress provider is one of the most used, or it used to be one of the most used, but is still a go-to in this case. So for those of you that are maybe not familiar with traffic Kubernetes or they didn't want to use it before, it manages access to cluster services by supporting the ingress specifications, pretty easy. And it also has circuit breaker at its level. So this is kind of a great thing if you're trying to implement circuit breaker in your distributed system, and it helps you a lot on that. So you can specify, as you see here, an expression, and you can give some parameters to this expression like the network error ratio or the status code ratio, or this kind of thing like latency at quantile in milliseconds, to give an expression when this expression, when it is matched, will trigger the circuit breaker and apply the fallback mechanism instead of calling your services. One thing that you should know about the fallback mechanism of traffic is that it's responding with an HTTP 503 response, something like service unavailable to the client, and it cannot be configured. So this is one drawback because you don't have access to the fallback behavior. You just get a 503 and that's it. So you just have to go with it. And it's not very fun. But on the other hand, if you are having the ability to manage things and you can choose between solution, the other way to work with is to go with service meshes, Istio. Some people are, kind of afraid of involving Istio in their already done solution. But in case that you want to better fine tuning of your circuit breaker at the level of infrastructure, the Kubernetes, you can use the Istio circuit breaker configuration, which is specifying the circuit breaker based on the connection pool, and of course on the failure, which is right here at the level of the outlier detection parameters. Now on the connection side, you can have, like in this case, either more than 10 TCP connections, or more than 20 HTTP requests, or more than 3 pending requests per connection that will trip the breaker. Now, on the failure detection side, any 2 consecutive errors occurring within 2 seconds of each other will cause the target host to be ejected from the load balancing pool for a minimum of 30 seconds. So this is kind of the interpretation of what you're saying here, and the configuration of the circuit breaker. So this is more, it's better in terms of manipulation and fine tuning, but it introduces to your system another variable that you have to manage, Istio. And some engineers don't like to introduce Istio necessarily in their systems, and they just want to be on the pure approach and try to keep it at minimum. I'm also pretty much with the pure approach and keep things at minimum until there are absolutely necessary to be added to the system. I think this was about the integration part that I wanted to tell you about. Now about the scaling results. So this is another anti-pattern that is being encountered when you are scaling, and you get some side effects that you don't want to, that you actually are troubling your system. So most of the time you see the scaling results or the effects of scaling when you get to this kind of situation, when you have a cone with a lot of resources accessing fewer resources. So anytime you have a many-to-one or many-to-few relationship, you are in this kind of anti-pattern. So when you're doing scaling and you get in the situation like many-to-one or many-to-few, always think like, will this kind of behavior indeed scale my workload, or will end up in becoming a bottleneck at some point in time? Also amplifying, the scaling effects are amplified by the shared resource or the commons project. This is something that comes from the era of layered architectures, when, for those that are Java-based with Java background, you do remember the ER applications where we used to have one or more jars, one of them being called common project. And the common project used to have all those functionalities that were common to the other jar files in our enterprise application. So everybody was using that commons. And it was like a nice approach at that time. It's easy to understand the commons project, but a lot of people are propagating the shared resource part also to the level of microservices, because they still have this, this idea back in their head, like, it's better to have something common that I'm calling and stores that logic and I'm reusing. So it's the reusability, the extreme reusability thing that is coming to our minds when we are designing and implementing. And it's a habit that you get rid with a lot of practice, and like to remember all the time that you need to stay isolated when you're doing a microservices architecture. So isolation, 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 and not too much of sharing. And of course, for those of you that are working with Kubernetes, well, you know, some people are likely to combine horizontal and vertical autoscaling because they realize that, well, I don't have only stateless applications. Some are stateful, and why not do both HPA and VPA? And of course, this is actually the result, this anti-pattern is the result of counterproductive usage of predictable demands and elastic scale patterns. So when you have understood that predictable demands and scaling are just something that you're just playing with it and you see what is going on further. Kubernetes is very smart, as we all know, but wrongly manipulated, it can get us to a lot of trouble. So why is this wrong manipulation of the scaling policies so bad? We can get to the situation when one or more services are flooding some other parties, and we're destabilizing our entire application. And the idea of shared project or shared resources, they mean a capacity constraint. So imagine that you're having like a small neck to a bottle, that it has a large mouth. Regardless of how much water you're putting in that bottle, you're still gonna have like that very tiny neck to put all the data that is going there. So you're having like a bottleneck in your system. And it's not very nice for the functionality that you're bringing to your system. So what solutions are? So firstly, a design level. Well, you have created a shared nothing architecture. So when you went for Kubernetes, you wanted to isolate yourself from what was bad before. You wanted to be happy with something new, much easier to manage from infrastructure point of view than what it used to be before. So you should be thinking again to your shared nothing architecture. And you should think on how to reduce the number of callers to the shared resource if you don't want to eliminate the shared resource. So at least if you want to keep the idea of shared resource, try to minimize the number of callers to it. Like, do all of the callers need to go to the shared resource? Maybe they don't. And another thing is to design for pairs of application that each other are acting as a failure for the other, failover for the other, so that you are kind of, bouncing. When one is failing, you have the other one that is ready to serve you the request, so you have availability for that. Now coming back to the Kubernetes level and using the scaling policies, there are some stuff that probably many of you have in mind when you're using scaling at cluster level or HBA or VPA. So at cluster level, a lot of people that are working with extremely large applications that are meant to serve global clients are using the cluster autoscaler, which is a very, very fine resource. Now, if you're using the cluster autoscaler, you know that you should provision the cluster nodes to have the same resource footprint. So you don't end up like, you don't go and design the nodes with different footprints to make the autoscaler's life much more difficult. Another thing that you probably should take care about is that, well, the cluster autoscaler is also a resource in Kubernetes and should also have enough resources as itself. So it's not some kind of entity that is floating somewhere in Kube and it's just triggering itself to make your life easier. And last but not least, my personal favorite in terms of working with the cluster autoscaler is to avoid delays in provisioning. You probably know about the over-provisioning technique, which is a very good technique to make sure that you are going to have a buffer of resources available for you. So what happens is that the actual time that it takes for the pod to be scheduled of a result of scale up depends on the scale up request. And a new node to be provisioned, it depends on the cloud provider. And this could be very well a delay of several minutes. So to avoid this delay and ensure that pods spend as little time as possible in the schedulable state, this practice of over provisioning is put in place. And this can be accomplished by using the pods, which are dummy pods that are spun up when you are setting up the node, just with the purpose to reserve space for other higher priority pods. So you can see that these kind of pods, they don't contain anything smart in their deployments, but they have the priority very low. So when pods with higher priority are going to come up, those are going to be prioritized and they're going to have space, and these are going to be evicted. So Kube's Kubernetes schedule will remove them to make space for those that are really important for us. So this is an idea like to have a buffer when you are trying to schedule a lot of resources and to lower down the delay in provisioning the space for those resources. You can find the GitHub over there for those of you that are much more interested about it. And for those of you that already know it, probably you know this resource already. So that's for the autoscaler. But when you're talking about HBA and also about VPA, there's some basic rules that you should always have back in your mind. And actually, when you are designing applications to run on Kubernetes, always your resource, you should have the resource requests defined. I think this is in every exam of Kubernetes. And that you should validate that those resource requests are close to the actual usage. So you don't like put resources to a usage that are just much more higher than you expect to have at the application level. So just fine tune a little bit more what you're putting there in the request limits, CPU and memory and everything. And another best practice for this part, the Kubernetes level, is to protect your pods by using pod disruption budgets for application pods. So to ensure that you have a minimum available pods in case that something happens and your application needs to be available after the eviction. So you are making it sure that your application is protected against certain disruptions that can occur at the level of the cluster. So always like try to fine tune these three. This is kind of like the basics in terms of working with Kubernetes and have things up and running. I think that they're in every certification specified, but in the examples that you can find over the internet, sometimes you will see that there are deployments or resources that are not configured until at the very level of the resource requests. And this can, induce the idea that, Kubernetes is going to take care of it. It will, but you have to think at the economy of your cluster when you are designing this. So now, and last but not least, of course, avoid using both HPA and VPA. It's everywhere in the documentation, but people still do it. And another thing that I would recommend, even though that a lot of people say that the metrics server is not something that they would use because it's not something that is having a general availability, and it's not present by default in the specification. But you can install it, you can play with it. And if you see that your HPA behaves better after fine tuning these custom or external metrics, then why not use it? I mean, if it doesn't hurt, you can probably use it regardless of not being part of the official specification and installation and so on. So you can tweak even more the things that you have over there. And of course, last but not least, to configure the cooldown period. So some admins told me at another meetup last year in Romania that they never had to configure the cooldown period. I'm not saying that you should go and configure it right away, but going and looking into the configuration of the cooldown period, it can help you speed things from when HPA is doing the downscaling. So by default, this flag has like 5 minutes specified. So this 5 minutes for the flag means that the duration of HPA waits. So HPA waits for like 5 minutes between the downscale events before initiating another downscale. So maybe you want to fine tune this to make sure that your cluster is more agile in terms of handling downscaling. And last but not least, I'm going to talk very fast about delayed responses because this is another thing that comes to our mind and happens still in distributed systems. So you're making a nice distributed system and it's still not offering you the instant response. It's still having delays and generating delays. So what happens? So this is typically the result of excessive demand or network congestion. Pretty standard. Everyone could have guessed that. But this can also be the sign that the application has memory leaks, and that's not very good. And typically it occurs because there's a counterproductive usage of health probe and service discovery patterns. And well, the problem is either at application level or at the level of the resources. So first of all, let's discuss why is it bad? Well, when an application, especially a web application, is slow responding, it means that it generates more traffic, I mean, whenever your website is responding slow to you, what do? You go and hit the refresh button and more requests are coming. So more traffic comes down the way to an already slow responding application. Or maybe an application did not gracefully shut down between deployments. It can happen also. This is how the memory leaks actually occur. So if something didn't shut down properly between deployments, something was not okay, it just remained there hanging. So first of all, you isolate the level of the issue. And if it's a network related, probably the first thing that you're thinking is like, it must be at service level. And if you're thinking at services, you can also think at endpoints as resources. So you should watch and describe how your services and endpoints in Kubernetes are going on. So you can follow those and then trim the search to those. And also, if you are having doubts that maybe it's an application problem, you can test the liveness in the readiness endpoints, simple curl commands, for example, and see how that behaves, and also look at the deployments, how things are going. So what messages are recorded in the deployments when the old pods are dying and new pods are being spun up? Is there any difference compared to the snapshot that you have in the from the monitoring system from the first week or the past weeks? What did happen? What changed? So you can isolate things like that. Now, if the problem is that the Kubernetes endpoints, for example, or is it the Kubernetes level, always remember that kube controller manager is the one responsible for rectifying the current state of the cluster with the desired state of the cluster. So this is the first one that you need to look into if you're thinking like, okay, it's a kube situation, maybe something needs to be fine-tuned. So kube control manager has a set of flags that can provide more fine-grained controls of parallelism. So if you are increasing some of these flags, you can make Kubernetes more agile when updating specs, for example. So the flags for configuring the level of parallels are usually -- concurrent. There's a resource name over there, and sync. You can find them all in documentation. And this can help you in specifying the controller manager how to consume, how to update the specifications, but be aware that when you are, raising these values here, you are consuming more CPU and more memory. So be aware with how much you're raising these. And there's, of course, some flags responsible for throttling API query rate. And these flags set the rate limit for all Kubernetes API requests. So whenever there's low responses, think at the Kubernetes API requests and maybe something is going on slowly there. And maybe you should fine tune some of these. These are like last resort things to do, but maybe the situation is at application level and you can fine tune it there and just that. But if it's not there, you can go upper and look at what's going on at the cluster level. I think I'm done with my presentation and just want to tell you that you should be aware of anti-patterns. And there are many more things that can go bad, but I already talked like 1 hour. And just remember that when something bad is happening pretty frequently, there's a chance that that becomes a pattern and not necessarily in the good way. So it's up to you if you want to change that or you want to create a new anti-pattern. So those being said, thank you very much for listening to me. I think that I'm done. And Alessandro?
Yeah, thank you, Anna.
Sorry.
Thank you.
I told you that.
Thank you.
Too much.
Thank you. It was nice.
It was a great presentation.
Great.
Thank you very much. But please don't change API server parameters. Don't try that at home. But unless you need, of course.
So that's just like last resort. So whenever you're dealing with the master, it's last resort thing. But it's worth knowing about them.
Definitely. I mean, it's so many things you can do with Kubernetes, but most people stick to the managed services. But I can't see any questions in the chat, so I guess it was all very clear. Unless anybody wants to intervene now or something to say, some comments to add. I mean, it's not just, we're not limited to questions. Also, if you have an alternative opinion, we'd love to hear it. But yeah, if there's nobody who wants to say anything now, I will just hand it over to Ramon. He also has an interesting presentation. So, and thanks for, I think Ramon will announce this WAG thing at his own time, right? Well,
thank you.
Thank you, Anna. Well, if you stick around, we'll have a final session, maybe all together. Thank you. Ramon?
Yes. Yep. Hi there. So first of all, thank you for giving us the opportunity to actually talk a little bit about the security and security on how we actually see that. We try to make it a little bit more interesting for you. So we actually have a Kahoot arranged with several questions, and my colleague Dan, who's in the call as well, will actually lead that after the presentation I will give. And there are some nice prizes to win. So please pay attention. Let me see. So when we're talking about security, let me get my remote control first away. So when we talk about security, sometimes we have to go a step back, right? And think about, okay, why are we moving to containers to begin with? So, I mean, a couple of years ago only, we basically building monolith applications. We updated those 2 or 3 times a year, and we all thought that we were doing a great job. But suddenly we somewhere actually we decided to make it faster. We had to be more agile, right? We had to be more being more able to actually create applications, do more scalability, etc. And then besides scalability, also speed comes in, right? So you want to go very fast, go to market. You have to be consistent in your delivery. And basically you have to release it as soon as you are ready, because the next release is popping you in the back already as well. So to be able to do that, you want to reuse particular elements that you have as well. So, and you want to reuse those on cross-platform in different environments. And as you can imagine, and as we all know, this means that you are moving fast, but it also means that from a security perspective, you have different challenges, right? So the security solutions that we had to actually protect the old monolith and VMs in environments are no longer suitable for protecting you in, let's say, Kubernetes environments, right? So what we see is that you basically have different maturity levels. So when you are starting and you are actually setting up your cluster, I mean, you have to make sure that you actually restrict, for example, the access to your kubectl, right? You have to define your airbag rules as well. Use network policies so you have visibility on your pod-to-pod traffic as well. And of course, the TLS certificates, because you want to make sure that the elements that are talking to each other actually are trusted as well. And then you go more into the hardening of parts. So it's very obvious that you have to keep your Kubernetes updated, but also use a minimal OS well, right? Because one of the reasons why Windows, but also Linux and what kind of versions you have are vulnerable is that they have a lot of services running on top of them. And a lot of services you don't even need, right? But they are in there because they're in the OS. So the big advantage that you have when you're running this in a container is that basically you can minimize the threat vector, because you can only use, you can only choose to use a service that you actually need in that container, right? So also again, RBAC, so use the minimum rights of rules you actually need. Make sure that you have your logging enabled, etc. And if you have the ability, and you can do that, verify the binaries that you are using before you actually use them in your deployments. And then you move more to the right. So from a protection perspective, what we see a lot is that a lot of services, even though we all know that we shouldn't do that, but a lot of services are actually running, right? So sometimes you even have containers running that have a dashboard enabled or other GUIs, and you don't even need that. And when you are a hacker, one of the great things is that you can actually, especially from a public place, dive into a GUI and try all these kind of different stuff, right? So like SQL injections, cross-site server forgery attack, etc. So, and then of course you can protect yourself with the WAF functionality, but still, if you don't need it, don't enable it. The same as the service account token, right? There is a default service account token. So in other words, if you are not defining anything in your YAML files, this is basically one that's going to be used, right? So it's not good security practices. And scan images for known vulnerabilities. And this is something you can actually do even before you are in your pipeline. So you can actually say, okay, when I'm trying to create a specific application, I'm using specific baseline images. What you can actually do is scan those images up front to see what kind of vulnerabilities are in there. When we look at the solution we offer, the Prisma Compute, the old Twistlock, is basically we have a Twist CLI binary you can use. So actually you can do rescans before you actually are deploying them. And that makes sense, right? And then from a prevention part, I mean, you use your pod security policies, right? Use key vaults, put your secrets in. Also, if you are actually able to use a service mesh like Istio, or if you want to have pod encryption, use something like Apareto, right? But this is all common sense, because when you are talking about security and when you are talking about securing your environment, you actually have to look at it as a layered approach, right? So, I mean, when you look at this, you have a cluster, and within your cluster, of course, you have several nodes running, and on those nodes, you have your containers running. So as soon as if someone who wants to do malicious actually is able to get into a container, they can actually break out of the container and get into the node, right? So, and then if you are in the node, because the node actually controls the pods, you have most of the time full access. And then if you get back into the master, I mean, you basically are controlling the cluster. And at sea, I mean, it speaks for itself, right? Basically, you have the full keys to the kingdom. So that's a bad thing. So actually, you have to think about protection and security on all these different layers. So you actually have to make sure that when you are running containers, they are safe, of course, from a runtime perspective. But you also have to make sure from a compliance and vulnerability perspective that you're doing the right things in your environment. So this is something, basically it's a short research. So, and what we see is that these are the common attack factors, right? And I mean, you can read through them yourself, but where it basically comes down to is to be able to actually manage this, you have to reduce your attack surface. So all the points I just mentioned are very logical, but what we see a lot in environments is that they are not that logical as we think that they are, right? Because sometimes it's work, and sometimes people don't have security on top of mind. They just want to deploy stuff and run environments. But these are the risk factors you actually have, right? So please keep this in mind. When we look at a sample of actually someone who's building something, right? Let's say you want to build a particular application. There are various checks you can actually do. So everything with the red circle is basically in your container environment. But when you are starting to build, as mentioned, you can actually do pre-checks, not only from a image vulnerability perspective, but also from an infrastructure as a code perspective, right? So you can actually say, okay, we have particular code that, let's say your Kubernetes YAML files, so you can actually check them. So that's a service we offer as well. So you can actually check if there are any, you can say misconfigurations in your YAML file before you actually pushed it. What you also can do is you can check your specific images that you have locally, for example, for vulnerabilities, and see what type of vulnerabilities are in interest of you, and actually see, okay, am I using the latest and greatest of a particular baseline image, or do I accept that this particular CV is in there because there are particular packages in the specific image that I need and I cannot do without. So what you can actually do is you can push your code, for example, in Git also, and then in Git you can do another check. So if you're making changes, you can even make the changes in Git. You can actually, by just defining another branch, you say, okay, this is what I'm going to change. Do we agree, yes or no? And then if yes, you can actually do another check. And then you can use that code in your pipeline again, right? So, and then you can push basically, or pull, depending on how you set things up, of course, but then you can make sure that Jenkins actually use that code and then pushes that code into your infrastructure, right? Or push this particular, do a check. Also, you can do that from a pipeline perspective. So if you are using Jenkins or CircleCI or Jar Jar or JFrog, we have native integrations with Jenkins, but we have the Twist CLI binary you can actually use for all the other pipeline tools that are in place. And what we can do is actually create another project. And in the project, you can actually specify if you want to do a check. And then based on the output of the check, the vulnerability check, you can actually say, okay, build or don't build. So you actually have control over what kind of vulnerabilities you think are acceptable to actually have in your environment, right? And then of course you can push that again to JFrog, and then you can use Ansible to actually push everything out, and then you have your containers running, right? But what you also want to know is, okay, what is happening on my nodes? So we can actually scan for vulnerabilities on the nodes. We actually map the services on the nodes as well, right? And we have, you can say, a layer 3-4 firewall on the node also. So with one agent, we are not only protecting your container environments, but we are also protecting your nodes, right? So, and we are protecting that not only from a vulnerability and compliance perspective, but also from a runtime perspective. So, and the way how that works actually is if you dive a little bit deeper into this, here you see an example of a build, right? So we are basically scanning particular images that you want to use. And then based on the outcome, you can actually say, okay, this build or project is allowed or not, and then it will fail. But what you also can do is actually say, okay, when we are deploying particular containers based on specific images, what we can do is we can actually have that particular container in learning mode. And we do this by default, right? So as soon as you deploy something, we will look at the container and all the network traffic that comes with different microservices and say, okay, this is what this particular container is doing. And then after an hour, we will actually monitor the next 23 hours, the baseline that we have created in that hour. And then we say, okay, this is a fixed baseline. And this is out of the box, right? So it's not something you have to do from a time perspective. You can also say, we want to do this for 5 days, or you want to say, no, we want to create a model in 30 minutes. So that's all possible. But as soon as we have created a runtime model, we will have a look at, okay, the behavior of the container. And if we see anything strange in that container, we will actually act on that, right? So if you, for example, have your front-end containers running, those front-end containers are being compromised for whatever reason, and now suddenly there are commands like nmap, or someone tries to download the IP utils, you can actually block that. So, okay, that's something we don't want. And of course, an alert is being created and you can do your forensics. Or you can even say, well, when we see this particular processes, just kill the container. We don't want the container up and running anymore, right? So you can actually use the Prisma Cloud Compute, also known as Twistlock, to protect your container environment in runtime. So this is just a short mapping on basically, and this is not only for us, this is basically what you should check when you are running containers in your environment, right? So this is just a general view on things and what we are actually doing. So it's always good to see some stuff, I think. So let me see if I can pop that up. Are there any questions in the meantime while I'm actually looking for the right screens?
Not that I can tell from the from the chat. Sorry.
Okay, cool. So as mentioned, we have several ways of actually checking things before you actually get into here. So just a short example, right? So this is how it looks like when you do a pre-check with the Twist CLI binary on what kind of vulnerabilities are in a specific image, right? So that's the first step. And then you can actually do the check as well, as I mentioned in Git, right? So you can actually say, okay, we go to Git, we adjust the file, we do a check, and then you get the output of the infrastructure as a code file, right? So those are two different things, right? And then what you can actually do is you can use that into your Jenkins as well. So you can actually say in your Jenkins pipeline, in a specific build, I mean, this is pretty simple, but just to show you how we actually do this, is you can actually create the build, and then in the build, oh, let me check. In the build itself, we do the checks, and then after the checks, you can actually specify, okay, these are basically the CVEs we have found, and then based on the severities, you can actually allow or not allow the build to continue, right? And the cool thing about this one is that actually you can control where it should fail or not fail. You can control that in the Twistlock GUI as well. So that's pretty cool. Then when you have actually deployed everything in your environment, this is how it looked like, right? So the first thing you will see is actually that we map the traffic and the behavior of the container. So it's very easy to see, okay, these are the network connections my microservices environment has, and then you can dive into it. Right? So we also do, as mentioned, we create a container model. So, and based on the model, we can actually take actions as well. So when you are saying, okay, from this particular container that normally goes through the catalog container directly into the database on a specific port, we can say, well, if the port changes or the front end tries to do this directly, you can actually say, send me an alert or even prevent that particular traffic. And then as mentioned, based on the baseline that we create for this particular container, you can actually have a look at this as well. So you can actually say, okay, show me the baseline that we have created for this container. So basically, what have we seen from a behavior perspective? And also you can see, okay, you can even adjust this if you want. So it's not something that you have to use like this. You can actually say, okay, I want to adjust my baseline. So I want to use what the compute environment actually has built. And then from a model perspective, I actually want to change that. So you can actually say, okay, this is how it looks like now. And then you can actually clone it. And then you can say, okay, I want to adjust it. And then you want to use specific services, or if you want to say, well, when I see a specific process in here, send me an alert or prevent or block even, as mentioned, right? Networking. So not only do we map what kind of folders a particular container is writing down to, we also map from a network perspective, what kind of traffic do you see, what do you want to allow from a port perspective, as well as from a DNS perspective, right? So there's a lot of stuff you can actually do. And if you want to customize this further, you can actually create your own custom rules as well. So there's a lot of stuff you can do from a security perspective, but it's good to know that it's not just one thing you have to check, right? You have to do a lot of checks actually before you should basically push any container environment into your runtime, if that makes sense. So, I mean, I promise not to make this too much of a pivot of our solution. So, but I hope you get the idea on basically on the security steps and where you actually have to consider what kind of security you should do. If there are any questions for me, then please let me know in the chat. And Dan, can you take it from here?
Yes, sure. Any questions before we move to the Kahoot?
I made you co-host, so if you need to present, I think you should be able to do it now.
No, I don't need to present. I just need to put in the chat. So you have the pin now. So the idea here is for us we wanted to give away some nice tokens. We partner up with some of the cloud providers, and we decided to offer 3 AWS vouchers, each of worth around $150. And we said, let's make this a bit interactive and have a bit of fun and have a bit of quiz towards the end. So
this is the part where we can actually check if you were paying attention, right?
that's now the test. If you actually listen to Ramon or not. Let's give it a few more minutes till people join. I see already 10 players have started or have joined.
It's not an exam. Also, it's Friday, so
yeah, you will see. It's quite easy. It's again just for us to have some Q&A and to spark some conversation. That was the whole purpose of this this, let's say, quiz. 15 people registered, so let's give it 2 more 3 minutes. Kahoot ID and the pin is 768366. $18 players. I see that there's quite nice acronyms. In order for for the folks who will win the top 3. In order for us to share the vouchers, we will ask you to come forward with your real name or forward that to Alessandro, and he makes sure that you get the vouchers. 22 players.
I mean myself, but you can witness that I don't know the answer beforehand. So he didn't share it with me before.
Yeah,
before
we didn't share the questions with Alessandro. That's true. Okay, so I think we have 25 people at the moment. I see that we have 51 participants. So 26. This is still going. Should we keep another minute, Alessandro? Or?
I think who wants to play is already in. So let's see how it goes. So yeah, I can see something happening.
So Dan, you mentioned you would sing on the background, right?
Yes. nobody chose the next one. Let's see.
Yeah, I haven't seen the question actually.
Dan?
And if you refresh, it gives you a new nickname.
Dan?
My Zoom just crashed. My apologies for that.
Well, that explains that we didn't see the questions.
So you didn't see any questions raised so far?
No.
Okay, so there's been 2 questions which have gone. It's the first time we're doing this, guys. So let me end the game. Okay. Okay. So this didn't go as planned. Let's start. Let's start again.
Does that mean that everyone has to sign in again?
Yes, because I think that we've actually done 3 questions and there was no answers in the questions. So I don't know if
Same pin?
nobody actually. Can you hear me?
Yeah, we can hear you. Yeah, is the same pin?
No, I think will be a different one because I need to restart it now. I don't know how to stop the music though. Do you hear the music or not?
No, we don't.
No music.
That's in your head.
Okay.
You were already dancing.
You're already dancing. Okay. So 3 now. Let me go back again. Chat. That's the new pin. I can actually even share my screen so that you can see. We've actually tested this earlier and it worked quite nicely.
Of course, no CI/CD on this one.
No CI/CD on this one, indeed. Okay, so I still have 25 players, so I'm going to start the quiz. And let's see if you now see the questions.
Yeah. Slowly,
Yeah?
question 1, yeah.
Ah, okay. So apparently I needed to share the screen also.
But no questions.
Could be maybe ad blocker. I'm gonna try to disable all my ad blockers.
Okay, that was the first question. Let's go to the next one. This is the score. Brilliant. Any questions or anything from the team?
Yeah, I also don't see the question, but looking at the screen, then screen, I can figure it out.
I think that's the idea. I think that you have to show the question then, and we can only
okay.
Yeah, that's correct.
So it's meant for a presenter to share the question in a slide, and then
Yes.
and then you just pick up the color.
So you don't see the screen. How long does Prisma Cloud take to create a runtime model?
No, Dan, we see the screen. The thing is that when we log in, we can only see the answers and not the question. So what you're doing right now works.
Okay, now read the question going forward.
Okay.
Okay, so a lot of people were paying attention. 1 hour is the minimum runtime model. Let's go next, where inserting security earlier in the development process is called what? Okay, shift left was the correct answer. Social Mercat is still leading. Do you know what number of containers get lost in the sea every year after falling off the ship carrying them? More of a fun question. Up to 10,000 containers are lost in the worldwide trade in the seas on a yearly basis. Just as a fun fact. Prisma Compute Security secures what? Correct, all of the above. Host, containers, and serverless functions. Another quiz. If you're not using the GUI, you should keep that enabled because it is handy. That is correct. We don't need to use the GUI if we don't need to have it. So let's go next. What tool was used in the build time integration? Jenkins, that's what we showed in the demo. Okay, what plugins are available out of the box from Prisma Cloud? All of the above, or all of this in the question at least. And the final question, just to make it short, what do you estimate is the percentage of exposed Docker containers that use insecure default configuration? So this is actually was a report or study performed by our Unit 42 on 21 cloud breaches. An interesting read if you want to get some interesting statistics. So let's see who won. So it's Gentle Egret on position 3, Tropical Condor on position 2. And Social Mercat.
All right.
So yeah, I would ask these three gentlemen to either drop a note in the chat with their email address or to send that to Alessandro, and we can share then the 3 AWS vouchers.
Cool. Well, good luck. Congratulations with the, what was it? AWS credits, right? So
yeah, I mean, we have some. It's the first time we're really running the Kahoot challenge, so we need to know how to do this better next time. But I hope this sparked a bit of a contest or a bit of an interesting idea. We do offer, for everybody's awareness, we do offer free trials, which self-service from our platform. So if you want to get your hands dirty, feel free to do.
Awesome. Well, I'm not even allowed to use AWS credits, so good that I didn't win. No, I am allowed. Thank you so much, Ramon and Dan, for this. And of course, Anna, for the great presentation. So this is the moment, because we do it in real life. When we used to do real life, we open the stage for lightning talks or people that want to share their experience, their either good stories or bad stories about Kubernetes. And it's a bit difficult here. Probably people did not prepare for this. Maybe I should be more explicit in the description of the meetup that you are welcome to present like an impromptu presentation, like a lightning talk. So, but if there's nobody else, nobody's prepared for that, then I will just close it here. We are just in time because we supposed to close around this time. All right. We are already planning for the next one, probably the first week of June. So keep an eye on the meetup page, and we'll keep updated. And yeah, and keep an eye on the KubernetesCommunityDays.org website for an update on the conference in March. So I hope everybody will stay safe and have a great weekend. Thanks again to the speakers, Palo Alto and Go to Amsterdam. to Natalie. She was on the call, and she's also running the Go-To Nights Meetup. Also, feel free to join that one as well. Thank you.
Thank you very much.
Thank you. All right.
Thank you.
Sandro.
Thank you.
Thanks,
Have a great
everyone.
weekend. Bye.
Bye-bye.
Bye.
Bye, everybody.
Bye.
See you.
Bye.
Bye.
Stay safe.